In this video, we are going to solve the integral of e to the x divided by e to the 2x minus e to the negative 2x. So the answer is provided on the right hand side. So to start off with this integral, we have I to be equal to the integral of e to the x dx. This is divided by e to the 2x is e to the x squared minus e to the x. This one is raised to the power negative 2. And now after doing this, I'm going to do a substitution. So I'm going to let u to be equal to e to the x. When I do this, du is going to be equal to e to the x dx. And now the integral in the u world, I is the integral e to the x dx is now du. This is divided by, this is u squared minus u raised to the power negative 2. This is the integral of 1 all over u squared minus 1 over u squared du. Cool. So we have I to be equal to the integral of 1 all over u raised to the power 4 minus 1 all over u squared. So you can multiply top and bottom by u squared, and that is going to be the integral of u squared all over u to the power 4 minus 1 du. Alright, cool. So now we are now going to solve this integral. So to solve that integral, what I'm going to do is to, looking at the denominator, I have the integral of u squared. The denominator is like difference of two squares, which is u squared squared minus 1 is the same as 1 squared du. So difference of two squares at the bottom, that is going to be u squared minus 1. This is multiplied by u squared plus 1 du. Alright, so here what I'm going to do here is I'm going to add 1 to the numerator and then subtract 1. That's like the Camel principle. So the net effect is 0, the integral is preserved. So we have I to be the integral of, this is now 1 plus u squared. This is divided by u squared minus 1 multiplied by u squared plus 1 du. I'm now splitting the integral into two different integrals, minus the integral of 1 all over u squared minus 1. This is multiplied by u squared plus 1 du. Alright, when I do that, there's going to be a cancellation. This one is going to cancel this one out. And now what you are left is I is the integral of 1 all over, this is now u squared minus 1 du. And this one is the integral. So what I'm going to do here is I'm going to add u squared and then subtract u squared to the numerator. So this is what I have, and I'm going to divide it by u squared minus 1 multiplied by u squared plus 1, like this. Okay, so this is what we have, and now we are now going to split the second one into two different integrals. So we have I to be equal to the integral of 1 all over u squared minus 1 du minus, now splitting this one into two different integrals, we have 1 minus u squared. This one is plus u squared. This one is divided by u squared minus 1 u squared plus 1 du. I is equal to the integral of 1 over u squared minus 1 du minus, splitting this into two different integrals, you have the integral of 1 minus u squared all over u squared minus 1 multiplied by u squared plus 1 du. And now minus and positive here, that becomes negative, right? Minus the integral of u squared all over u squared minus 1 multiplied by u squared plus 1 du. Cool. There's going to be another cancellation, not yet. So we have I'm sorry about this. So this one is going to be I, which is equal to the integral of 1 over u squared minus 1 du minus this one. I'm going to reverse this, that is going to be negative u squared minus 1 on top. This is divided by u squared minus 1 multiplied by u squared plus 1 du. And now minus the integral of u squared all over u squared minus 1 multiplied by u squared plus 1 du. Okay, so we are now going to cancel this one out, and now what is left is I is equal to the integral of 1 over u squared minus 1 du. And this one, negative negative, that becomes positive, right? So this is positive, the integral of 1 all over u squared plus 1 du, minus the integral of u squared all over u squared minus 1 multiplied by u squared plus 1 du. But what is this integral? So when we go up, that integral is the same as I. So when we started with that, that is this one right here. So that is the same as I. That is what we have. I is the integral of u squared all over u to the power 4 minus 1. So when we go down here, u squared all over u to the power 4 minus 1, that is the same as I. So I'm going to rewrite that. This integral I is the integral. This one can be written as negative 1 all over, this one is 1 all over negative into 1 minus u squared, like this du, and this one is plus the integral of 1 all over 1 plus u squared du, and this one is minus the integral of u squared all over u to the power 4 minus 1 du. And we can see that this one is I, right? So we can just replace that with I, the one we have at the left hand side. So we have I to be equal to, this one is negative outside, the integral of 1 over 1 minus u squared du, plus the integral of 1 all over 1 plus u squared du, and this is I, that is this integral. So we can add I to both sides. When we do that, we have 2I on the left hand side, and that is equals to the integral of 1 over 1 plus u squared du minus the integral of 1 all over 1 minus u squared du. So we know this. So the integral of 1 all over a squared plus x squared, this one, let me not use that. This we have integral of 1 plus x squared dx. This is the arctan of x, right? And when we have the integral of 1 all over 1 minus x squared dx, this one is the tan hyperbolic inverse of x. Right. Alright, so that is what we have. So this one, the first one is the arctan of u. So this one is the arctan of u. And the second one is the tan hyperbolic inverse of u. We are done. You can put the constant of integration. You want I, we can isolate I by dividing both sides by 2. You have 1/2 the tan inverse of u minus 1/2 the tan hyperbolic inverse of u plus the constant of integration. So maybe you have like 1/2 c, which is the same as c is a constant. So now what is the value of u in terms of x, because the integral must be in terms of x. So u is e to the x. So we are going to replace u with e to the x, and that will be the resulting value of the integral. So I is going to be 1/2 times the tan inverse of e to the x minus 1/2 times the tan hyperbolic inverse of x, e to the x, plus the constant of integration. And this one matches the answer I gave in the beginning of the video. Alright, so when you go back up, we see that the answer I got is equal to the answer I provided at the beginning. So that is how to solve this integral. If you find that helpful, consider subscribing to Calculus Diaries and give me a thumbs up so that I'll continue uploading engaging tutorials on integrals. Thank you so much for watching, and I'll see you in the next one. Bye bye.